hesitate to interrupt me.
Professor, is it okay if I record this presentation?
Yes, no problem, of course. Yes, sure.
Okay, it's being recorded then, thanks.
Yeah, I will switch to presentation mode. So I was asked to talk about innovation management, in particular on cyber-physical systems. I'm happy to do so. So I will end with a couple of questions to discuss, to see whether you recognize what I'm telling and whether you see this happening to the world as well. But of course, in between, you can also pop your questions if you want to. I'll try to. So a few words about myself. My name is Jeroen Voeten. Voeten in Dutch means feet. So that's where the name comes from. I have a master. See where I can. No, I cannot do that. So I have a master in computer science. I did my PhD in electrical engineering quite some time ago. Currently, I'm a professor in the Department of Electrical Engineering with a chair on performance engineering for high-tech cyber-physical systems. So in the region where we come from, it's called the Brainport region in the Netherlands, is actually well known for rather complex cyber-physical systems, like the systems that ASML makes, the lithography systems in the semiconductor industry. So I also play a role as scientific director of a center, Cyber Physical Systems Center in Eindhoven. And in between my academic career, I had 15 years of experience in industry myself. So I worked for ASML for 15 years, giving me a lot of insight in what's going on in industry. And there's a huge difference with the way of working in academia. So from that, I learned a lot. From that also my passion, my professional passion came, and that's actually really cross-disciplinary research, connecting academia and industry, and bridging also between research and innovation, actually make research really land in industry, etc. Okay, a bit about the center. I will give you first an overview about the center, and then we'll go to the main topic about innovation management. So this is a multi-departmental applied research center with 4 departments on board. So we have electrical engineering, mechanical engineering, applied physics, and mathematics and computer science. And we focus on high-tech cyber-physical systems. So you know what cyber-physical systems are. They are systems that have a deep intertwining of the physical world with basically the control world, the computer science world. Application domains are semiconductors, printing, automotive, so all these more complex systems. Now, the mission of our center is to, it's an applied research center, so we are close to industry. So the mission is to empower our high-tech industries with disruptive technologies and methodologies to push performance and increase labor productivity. I will come back to that. So methodologies, you have to think about things like systems engineering methods, design automation to enhance efficiency of the design trajectories, multiphysics modeling, digital twinning. These kinds of topics are very important, but we also work on technologies in the different areas like power electronics, mechanics, electromechanical actuation, motion, contamination control, etc. So we cover rather a broad field with all the expertise that we have in-house. So if we look at the industrial challenges, what we see in the Brainport region in the Netherlands is that we talk about systems, cyber-physical systems, which are extremely complex. So we talk about systems with extreme system performance. For instance, a machine of ASML, we talk about nanometer precision and high productivity. So processing wafers with high speed. And it's a very difficult combination to be both very accurate and very fast at the same time. So, and these systems, they have to work under extremely well-controlled physical conditions, like pressure, very high pressures for certain, or temperature. You have to be very constant in temperature on a nanometer scale. Everything is fluid, everything moves, so you have to be controlling the temperature, for instance, very accurately. And further, we talk about high heterogeneity. So we have systems, have mechanics, electronics, software, and especially also deeply intertwined physiochemical processes that we have to control. What happens with that is basically that we see a steep increase in complexity. And here we draw it as in a picture. So this is a typical picture we use from the electronic development, so the EDA world, is that the green line shows what we could physically realize in principle regarding performance of these systems. And we see what we can actually achieve with the current technology and methodology. And there is a difference, and that difference is growing as a design gap. And that means it's getting more and more hard, more and more complex to cope with that increasing complexity. That's our biggest challenge of our high-tech cyber-physical systems industry in the Netherlands. On the other hand, we see that the demand for highly qualified engineers exceeds the offer that the labor market can provide. That's another challenge. So everyone is looking and spotting for high talent all over the world to make these ambitions happen. A bit about the organization. We are 4 departments, 9 groups. At this moment, 55 scientists delivering all kinds of expertise in many subfields. We have something special. We call that industrial research fellows. So these are not professors that we attract from industry, but these are people that have an architecting role on a high level in the companies, having insight in strategically relevant applied research themes. So we have these people in our center. We have several program officers that drive the program project development, attract money. And we have academic industrial steering boards to direct our vision and way forward. Okay, let's now come to the main theme. That's called innovation management. I was asked to talk about that. I looked it up. I found this a rather nice definition. These are the principal processes required to create long-lasting advantage and produce dramatic shifts in competitive position. And here I talk from the, not the industrial side, but from the perspective of the academia. We want to be competitive in the sense that we can attract money, we are visible, and we are engaged in large research projects, right? That's what we would like to achieve. Okay, that's what I'm going to talk about. But first, indeed, about some observations I've seen over the past 30 plus years. So when I started as a assistant professor, it was very easy to attract money for a PhD student. I just knocked on the door of my management. I said, we need a PhD student in this direction, and there was money. Very easy. But nowadays, it's different. So we see that the external agendas, they seem to determine more and more the content and the direction of science. So first of all, we see that companies increasingly request to address complex challenges that no one of us can solve on our own. And that requires cross-disciplinary collaboration. And secondly, even more importantly, maybe, the governments, both on the Netherlands but also EU level, they drive mission-driven research. And that targets basically what we call grand challenges. These are the real big challenges we have, societal challenges on climate, on health, water, energy, soil. You find these 5 topics on the EU roadmaps. So they ask us huge questions that none of us can actually solve. We can only solve a very small part of that. And what do I see as a consequence in our departments, and as I see especially for young scientists, this is really difficult. So what they are forced to do is to explain the impact of their own research contribution to address these complex grand challenges, which is actually completely beyond the scope of their expertise. That's difficult. We see all of us have to oversell our research contributions. We have to claim way more than we can ever achieve. We are required to establish more tight relations with industries. We have to compete with our fellow scientists to get on board of research initiatives, right? And sometimes that's not a fair competition. We have to collaborate more and more to actually address the real complex problems that our society has. But at the same time, and that's difficult, you have to develop your own research vision, right? That's different. I will show that in the next slide, what the difference is. So there are basically 2 dimensions of research. So here in the horizontal line, which is colored blue, I'll call that from the academic side, it's the supply side. So we as academics are rewarded to be worldwide renowned in our relatively small area of expertise. And here, of course, you have on the departmental level, electrical engineering, mechanical engineering, computer science, applied physics, chemistry. But there are many subfields. There are hundreds of subfields. That's we want to be the best in the world. And we compete or we work together with the best experts in the world to achieve that on our niche, on our small domain. But we have the demand side, the governments, the large industries. They ask us to solve big problems, grand challenges. And we can never do that on our own, so we have to work together to do that. And here we have the themes, the climate, health, water, energy, soil, industrial challenges. Now, a little bit more tangible, as an example, in the Netherlands, we have a big program. It's called the Growth Fund. It's a program of €1 billion, developing technology and processes for next generation chip assembly equipment. That's what we want to achieve as the Netherlands. But we need many things for that. We need knowledge on power electronics, on mechanical stages, on actuators, planar actuators, motion control, contamination control, etc. We can list many, many different competences, different science fields. And that brings us, I forgot to mention that 2 slides ago, in what I would call an academic split. And my question later will be, do you recognize that academic split? So you have to excel in your own field of expertise, at the same time react to societal problems, which you cannot address by yourself. So one of the things that we do as a center, we try to deal with this and to help scientists to bridge that gap, to deal with that academic split. And I'll start with the blue ones. So and that's on the academic side. And that's what we call develop research propositions and make our strengths as a researcher known to the world. These research propositions are discipline-driven, but try to make a connection to the complex ground challenges. And we try to help our researchers to bridge that gap, to create visibility. I'll come back to that. And second point I will discuss is to also work on the vertical axis to develop cross-disciplinary research roadmaps, which are more challenge-driven and explicitly connect to many different disciplines. And I'll have a question for you as well later on, whether you see that we should actually be engaged as universities to do this. Okay, let's first zoom into this, right? So to develop research propositions, more the vertical X discipline oriented. So let's say, why do we do this? And we found many reasons. So first of all, what are they? So they are basically small 2-page containing research propositions that sharply connect our research to the societal and industrial challenges. So why do we do that? Here you see a couple of examples, by the way, on the left. So we do that to help researchers to develop their own personal research strategies and visions. We think that every researcher should have that. They should know 20 years from now, I want to be renowned in this domain. This is what everyone should recognize me for. We do that as a step up for research proposals. NWO is our governmental way as an instrument to obtain money. We use that as a step up for personal grants, Veni Vidi Vici, ERC grants, etc. We use that as a starting point for collaboration matchmaking to get on board of, for instance, EU project proposals. We use that for advisory committees, if you want to have a promotion from assistant to associate or associate to full professor. We make it for getting more visibility, for research reviews, and especially also to connect to research roadmaps. Okay, so how do they look like? So research propositions are inspired by, you might have heard of Sinek's Golden Circle model, explaining that people don't buy what you do, they buy why you do it. And it's built on a why, how, what approach. So we made that more scientific. So we have a why in those research propositions saying, okay, what's a opportunity? And the opportunity is not the opportunity of the scientist, it's the opportunity for society or for an industry. And as an example, it's about fast charging stations in the automotive area, where companies want to deploy fast charging stations to get rid of range anxiety and to deploy them. Now, a roadblock is a reason why this has not been developed yet. And this case is that, for instance, the grid connection equipment costs are too high. And then the how comes in, which is a research hypothesis. And research hypothesis says, okay, what can we do as a researcher to deal with that roadblock? And one of our scientists was able to reduce the cost of such a system by 20% by a certain kind of solution, by a certain kind of what he's called an RDC system, a power converter. And that's the what. Now, what we see is that if I ask scientists what they do, they typically explain the what. They explain a lot on their deep knowledge about a certain domain, but find it very difficult to explain it in a bigger context. What is my value to the world? What's my value to actually solve big problems, grand challenges? And this is a quite systematic way to do so. So a bit more how they look like. So they are just 2 pages. They have an abstract. There's a certain person involved, of course, and there are corresponding paragraphs that elaborate a bit on the why, how, and what. So we have this opportunity explaining in a paragraph, this is about this fast charging station as an example. There is this roadblock, then a research hypothesis, and then only then the solution direction, but also research questions. And why do we have research questions? Because we talk about research, which is about risk mitigation. An hypothesis is an idea how to crack these problems, but of course there is risk involved. And to mitigate the risk, we have to solve these research questions. We have to get answers, and that's exactly the reason why we need research, right? And then it ends with a couple of references to underpin the story in a quantitative way. Now we do this with all our scientists to make their proposition sharp. I'll come back to that, but we have many successes with it. So this researcher started off, had no contacts with industry. We helped him to create his vision sharply on paper. And within a couple of years, the first project proposals entered. So he had this nice Marie Curie E2Go project granted, 4 PhD projects. Currently, he is in a position, he has so much work that he cannot even attract new work at this point. And this is one of the reasons why. Now we help our scientists, often case the more junior scientists, to develop their research propositions. We have a mentoring process in several steps to sharpen the ideas, and this is the whole process to get this on the go. Going to switch. What we also have done is to put this in a brochure, in a booklet, to show what we can all do as a center. What proposition do we have to the world? And make the visibility for all of each and individual researcher, make that transparent. So often case you see that the professors that are already working for many years at university, they always are engaged in many proposals. But we like to create the visibility for all the researchers and get the work towards the right competence, right? And to avoid the competition that is not fair sometimes. Now, this booklet was used, for instance, in a ECS brokerage event in Brussels to get on board of larger research proposals. This works quite well. Now, this is step 1. And next, I like to go to step 2, which is not so long. It's a little bit shorter, and that's looking at the demand side. So looking at the challenges, the ground challenges ahead, whether we should do something as a university in that direction. And I have some questions for you. I hope you have an opinion about it that we can discuss. I like feedback on that. Now, these cross-disciplinary research roadmaps, they are challenge-driven, and they explicitly connect to the different disciplines we have in-house. So first of all, a roadmap. So what's really a roadmap? You might have seen many roadmaps, but if you look it up in a good medium, you see that a roadmap is basically a detailed plan to guide the progress towards a goal. Right? For instance, a goal 2040, 15 years ahead, to obtain a goal together. And then a roadmap actually decomposes such a top-level plan into steps that can be, that are manageable. And this plan is created, executed in a collaborative fashion between academia and industry, having a common ownership. That's what it actually is. Now, there are many roadmaps around, both on EU and the Netherlands, for instance, which are not completely doing this. So it's often a collection of ideas, a collection of visions, but not a sharp plan to have a common goal that you would like to achieve. Now, a good example is what we see in the semiconductor industry that have quite a good roadmap to say what's our next step, what's the next node that we have to develop. So that these are huge collaborative initiatives to get to the next node in the semicon industry. So why is road mapping important? So it's important because the bigger and further goals, you can get them in shorter time and they become feasible if you have that in your horizon, if you define that spot on the horizon. It can further significantly improve the relevance of our research if these spots on the horizon are chosen well. Especially if you create such a roadmap collaboratively with industry, it instills ownership. Everyone seems to want to work together to get there. And further, the roadmap gaps, they provide opportunities for other parties to step in. It's actually very important to get this collaborative vision and the will to work on this together. It is really difficult. I've seen many projects in which multiple groups of universities were involved, but often case people go in the end in their own direction. They solve their own little problem and not really having a common goal in mind to really contribute to that. And that's what we like to achieve. So how would that be materialized? So we also use these research propositions where we have some top level explaining about the long-term goal and then basically making a decomposition in sub-goals until the level of concrete goals at the level of PhD challenges that can be executed. That's really difficult to do. So we do that together with a whole bunch of industries, 25 or more industries in the Netherlands to make that vision for a certain research theme. So, and we do that per research theme. So research roadmap, and then think about research theme about, for instance, design automation, systems engineering, also technology areas like cryogenic mechatronics, which is an area about mechatronics on very cold temperatures in which you get superconductivity, for instance. And the themes are identified in strong collaboration with industry and also groups of industries that like to work together. For instance, we have a group on mechatronics in the Netherlands. And we use that as a sounding board to develop them. This is difficult. So we need people to be able to set this top level research vision. And often case we see that scientists do not have that overview. They know everything about their own subfield, but do not have the overview about such a theme, the vertical lines. So we have research fellows on board, which are industrial senior architects from industry. They don't have a scientific background, but they well understand the way ahead that the industry goes. What are the big problems that the industry has to solve? And further, and I put them between quotes, we like to work with scientific, what I would like to call scientific architects. And we have those, but they are very scarce. These are people that have a very broad knowledge, but also have of course, their deep pillars. They have really deep knowledge about a certain area, but also able to look at the big picture and connect big problems with science. And these people are very scarce. I know that, and also they are not really in our academic system rewarded for this kind of job, because you are rewarded to excel in your research domain. And of course, the lower we get, the more we can come close to the scientists, the experts that know everything about their research field. Okay, so this is was my last slide. I'm not sure how much time I took. Okay, maybe almost half an hour or something more. So I would like to have a discussion with you. So we'll switch to a couple of questions. I hope there can be some discussion. Now, first of all, question is, do you recognize this split, academic split? So that first of all, you have to excel in your own research domain. And secondly, you are challenged to work on bigger challenges, to put all your science into a bigger context, etc. Just like what I all explained before. That's question one. Maybe someone can react or not. I mean, I understood there are we have PhDs on board, PhD students. We have also professors in the audience. Maybe they can react first.
People were shy to begin with.
I understand. I understand very well, but I know they're all just every idea that you have, or question, whatever, is okay.
So can you hear me? My internet connection is quite blurry. I don't know if you can hear me good now.
I can hear you, yes. Yeah, I cannot see you, but yeah, and I can see you as well. Yeah.
More than actually recognizing this academic split or any of these questions, I felt very identified with this challenge of like, let's say, scaling up this narrow research gap that we are devoted to. So normally I am a very electrical machine guy, now even electrical machine and diagnosis, but when you read European calls or even national calls, is, as you said, mission oriented. So it's like hydropower generation or even other challenges around automotive, etc., etc. And it's very challenging for me. Like I am a young researcher, 6 years of research experience. Is really difficult for me to come up with real ideas to write down in this kind of proposals. So it's actually not answering any of these questions that I really got identified with when you mentioned this.
Yeah. Yeah, but so you actually recognize this academic split. That's what you say, right?
Mm-hmm. Yeah.
Yeah. I think it's really a challenge ahead. Other people that have some.
Can you hear me? Maybe
yes.
I would like to make a remark on this point. Well, I'm not a very young researcher anymore, but I'm in the direction of getting experienced researcher. Maybe it's interesting to get experience in this language, which is asked for actually, and using the terminologies and maybe rewording your own scientific focus, and to make sure that the other party understands in their own language. Industrial experience is highly appreciated. So in Netherlands, we have a lot of people like myself who are part-time working at industry and working in the research institute. So it could be also interesting 5 days, maybe if you could actually devote one of your days for industrial party, because this is actually kind of training in itself as well. To understand what is the thought direction of the industry, what kind of words they are using, what kind of formulations, and that you are cooked in this direction. This is one way. Another way is you need to be visible. So you need to show yourself. Jeroen, in the beginning of his presentation, already mentioned several funding channels. There are many more, of course. how are the researchers in your field are presenting their work? Where are they gathering? Because there are so many actually gatherings at European level, at local level, and just by listening to them, talking to them, so this is networking actually, what you are also doing a bit today, then you can gain experience in this language, and then that you show yourself, and then attend writing proposals, because this is also how you are shaping your own, like Jeroen already mentioned, but being visible, so devoting your time in this kind of events, because the more experience you are getting, the less time you might have, but do not forget, we need each other, like Jeroen said. Industry is asking for collaboration, and yeah, research institutes are asking for collaboration and knowing people. And the only way to do this, actually, one of the most strong parts is writing together proposals. This is also becomes a bit like a shark game. That's my so people would like to sometimes just work with the people they know. So some groups could be a bit closed. So in this case, you can always ask for an experienced person in your research groups. So talk, not just your supervisors, but get out of your comfort zone. What are maybe other departments are doing? Just the talk, because you can have different input from another professor or associate professor, another department, maybe talking to electrical or mechanical, also in this consortium. So this is actually one of the main aims also of the TARTIS, to make this networking and this training and carry over this lessons learned. Yeah, I just wanted to share this is at least my experience. I think, yeah, Jeroen, also you said already some of the things I mentioned already.
Yeah. Yeah, these are very good points. I think, and I see it many cases in also our PhD students that often focus and feel that they have to focus a lot on their own research, and sometimes do not see or appreciate the discussion with people that work on a slightly different challenge. But I think in the end that's often worthwhile. Many of the ideas that what I personally developed in my career was always on the boundary between other disciplines as well, and getting inspired by other researchers that do something completely different that may on the first sight have nothing to do with your own topic. And I think we really need that. And I think society needs that, industry needs that we really start to work more closely together. And that starts also really at the level of the PhDs to actually open up and be more willing to understand each other's problems and think with each other to crack these problems. And so I completely agree. I think, by the way, it's also very good if academic people engage some period of their career in industries, actually really understanding. So SNF does it, of course, because of her job, because you will learn so many things that you will never learn in an academic setting. As the goals are different, the way of working is different, the questions are asked are different, everything is different, and you will learn to appreciate that. And initially this may seem like something weird. So initially what I encountered when I entered industry, one was asking me business cases. And for me, that was really weird as a scientist. I say, yeah, please leave me alone. I know what I have to do. But after many years, I really appreciate this. So and we try to, this helped me to understand how to bridge these gaps. So yeah.
I think it's a dual problem because myself, I did my PhD in an industrial environment, and then I switched to academia. So I did actually the inverse way. So I was working in industry during my PhD. Actually, Claudia Martis was my PhD supervisor, and I was in Siemens, that is also involved in this project. And in my postdoc period, now I am in academia, and I found actually a huge problem to advance in academia coming from industry.
Yeah.
That is related to the of let's say, I like to say it's silly publications, because sometimes in academia you have to build your career based on publications, and a lot of people publish things that are really meaningful, but they help on building a career. So personally, I don't have this kind of publications, and I struggled at the beginning a lot to scale. So it's just a curiosity, because it's in a bit the inverse way.
I completely agree and recognize what you say. Yeah, absolutely. Yeah.
If I maybe can add something as well, I'm not sure if you can hear me, but yeah, today's topic was quite interesting because we had, I would say, in the first session, more like a startup vision or industry vision, and then now going, let's say, more towards this academic vision. But it also shows that maybe this dichotomy between those two universes can be bridged together, right? Because on presentations, for instance, you presented that concept of why coming first rather than what. And it's the same approach that we had in the presentation before. So at least for these more applied research or shorter horizons, maybe a more entrepreneurial approach for the research projects, or at least having this customer perspective or the value or the mission coming first and bridging those two together can help exactly breaking this dichotomy and the discomfort that Jose mentioned, for instance, of the values not necessarily being aligned, where in the longer vision, they are actually aligned. So they should be the same.
Yeah. Yeah, I agree. But what I really do think is that academia should remain excelling in their own research field. So we should not intertwine and intermingle these worlds. They have their own existence, right? So we need to be the best in the world on our own research domain, and at the same time advance on the bigger themes that are cross-disciplinary. I think we need to stick to that. If we do not do that as universities, looking 10 years plus ahead, who else is doing that still? I don't see our governments doing that. I don't see industries doing that. So we need to. But that's my opinion, a personal opinion.
Why is that needed, or what's the motivation behind that?
That we need to be excelling in our own research domains.
Yes. So the innovation is coming from within.
Because if I am quite convinced that if we start working only on applied research, solving the problems at hand, we will not be focusing on the far enough future anymore. That's what I think.
I'm asking because I somehow agree with Kyle that at some point both the visions should be aligned, that the scope of scientists or the vision of scientists should be somehow the one that, or the other way around, the European Union's vision should be somehow aligned to that of the scientists. So somewhere on the road they should pursue the same goal, right?
No, I don't agree. The point is that researchers excel in their research field. But that's only one, they can only contribute so much to the big problems that we have to address. But the competence is really important, and you have to be very good. Otherwise, you will not be able to solve those big problems. So they should be related, but not be aligned. These are different dimensions. If you look at a big company, they all work on, for instance, to put a new product on the market. But there are many disciplines involved, and these disciplines need their own keeping up with their own knowledge and develop their own knowledge in the field. And that should not be confused with the product roadmap that is being devised. Right? So, and I think we need both directions, but we need to connect them. Not confuse them, because they are different dimensions.
It's not one or another, but at some point they intertwine together.
Yeah.
But like,
yeah,
if we lose the visionary aspect of research, in a way that research always kind of waits for the demand for industries, that's something that can also not happen, because
yeah,
the priority, how the priorities are placed for industry are more like in shorter horizons first, right?
Yeah.
So then maybe the research wants to catch up with the demands, it's too late.
yeah.
That's why also it's necessary financing.
Yeah, completely agree. So often case you see research being performed, novel things being developed that are only useful maybe 20, 30 years from now. We should keep on developing those novel ideas, even if we, at this point, we have no clue how to apply them, right? So if it's ever always driven by missions, you will never do this. So we need to be, have our own academic sovereignty. We need to keep that. That's why we should connect these worlds, but not intertwine them too much.
I have also a question. It's related to the research roadmap which you presented, and which I like a lot. But it's more adapted to the Technical University of Eindhoven and to the Netherlands environment. Let's say it's a successful story. But my question is how we can replicate that research roadmap to other or to other environment, not to what you have now in Netherlands and the universities. So how we can apply on other universities partners of this project, for example.
Yeah, thanks for the question. Good question. So, in my opinion, this approach is independent of the domain. I gave examples from indeed the Eindhoven region and what's going on there. But the approach of making research propositions, the why, how, what approach is very broadly applicable. I don't think it's connected to any of the research domains or application domains. So I think this is useful in many contexts. That's what I think. But it's good to try it out. So I see we started with electrical engineering in the TUE. And now it's broadening, spreading around in the university to other departments, with the mechanical engineering, computer science, and it seems to always work. We even have propositions directly with industry as a sort of contract. So that also works. So it's the simplicity of the formula is, I think, the power of it. Yeah.
Thank you.
Yeah. Okay, maybe coming to the second question, and that's for me maybe the most important one. So, what do you think? Should universities take the lead in developing cross-disciplinary roadmaps? So the vertical axis, should we do that? Like making roadmaps for these grand challenges about climate, about water, about food. Should we be engaged in that? Currently, we don't do that so much. We are seeing as technology providers often case, we don't do that. Should we step up and do that, take the lead?
Yeah, from my point of view, yes, university should take the lead, because in university there are a kind of freedom which doesn't exist on the industrial environment. So from this point of view, where in university you have younger researchers, you have freedom like to decide and to select the topics on which to perform or to do research. So yeah, from this point of view, I expect that the universities to take the lead and to on the innovation sector, let's say.
Yeah, I personally agree with you. Are there other opinions? Maybe people that think that that should not be done. Maybe simply because it's not our ball game. Or we never did this before on such a scale.
Well, if I can say in the case of Spain particularly, even like if Spain is fully, if not 100% aligned with EU, universities, in my opinion, in my little experience here in academia, are not engaged at all. At least the technical departments were what I know the best. Maybe I may know some cases where university personnel is taken as for consultancy for some public entities, but it's not the common practice, let's say. At least here in Spain. I know a little bit in Belgium because I used to live there for a long time, and I think universities there take more responsibility than in Spain, as far as I'm concerned. Probably it's the same in the Netherlands, but I mean, this is coming from my little experience here in Spain in academia. I don't know. Maybe for you guys in the Netherlands, it's completely different because I think in the system it's as Khalil, it's a huge gap still. So that's my point of view on this.
Okay. Yeah, in the Netherlands, it's also not the case. I see certain people doing this for sure. But if you look at the academic system, what I would call the scientific architects, they are not rewarded for this particular role. Because you are rewarded for your getting, grants, doing your research, getting publications. That's how you grow from an assistant to an associate to a full professor. And not because you do this large, you also have that in the rewarding system, but if you do this is difficult to publish. We all know that it's very difficult to publish cross-disciplinary research and doing, right? So it's more management than,
But isn't it providing more benefits? So if you try to apply, so you came up with something and you try to apply it in different places, that means that you're extending horizontally. So it means more publication possibilities, right?
Yeah, it's not so easy. It could work. That could work, but
So
doing this kind of work, that means that you are actually not publishing a lot yourself anymore. You are coordinating and making these kinds of large proposals and actually manage setting up projects or programs. So that's a little bit of a different.
One simple example that it's in my mind from a previous presentation is that one startup company came up with a ecological thing for sugar, and then they applied it for the same principle to wheat and for other parts. So that's what I have maybe in mind. So come up with innovation that's good for in technical universities, but then you go to the agriculture or some other place and try to apply there. You still have the expertise, so they need you to apply that one, but you lack the knowledge from agriculture, let's say, and then in collaboration make another.
I completely agree with that, but what you now tell, I think, is that if you look at this picture again, you explain that this blue line, which may be your expertise, can be applied in different themes. And then you leverage your knowledge to different themes, and that gives you publication opportunities for sure.
Which are rewarding.
But my question was, do we as universities develop these along the purple axis? Do we take the lead in developing these long-term societal roadmaps? Do we do that? Or do we stick to our horizontal lines?
Usually we stick to our blue lines, I guess.
Yeah. Okay, any more thoughts? Go to the last. Anyway, this is for us a challenge to address. Also, you might know, so in the Netherlands we had, of course, Philips. Philips still exists. Philips used to be the innovation motor of our region. They initially had lots of technology in their hands. They developed everything themselves. They even developed toilet seats in the initial time because they developed records made of a certain material that can also be used for toilet seats. And along the way, of course, they narrowed their portfolio. But we had the NatLab, and NatLab was actually the innovation motor. So they developed the CD player. They developed many new things that were launched on the market. But our NatLab has gone since this year. So that role is not there anymore. And that's actually our challenge. So how do we deal with that? And that's along this vertical X. Who should take that role? Who should take it over? Are we that as universities or other entities? Okay, maybe one of you, one final thought about it. If you have later, you have things, you can always send me a mail, of course. If you have ideas, I'm open to that.
I think it's just before the lunch break, so their energy is also a bit dropped.
Of course,
most
I
probably.
understand.
Yeah, well, maybe I have one more idea to add to this. So I think it's so we need to first solve the problem of so what we want as a humanity, right? So where do we want to end? So and then define this. So who is defining these purple things? And again, comparison to previous presentation, there are two ways to push things forward. It's either it's a market need, right? So somebody needs it, like you said, the European vision. So that's I would make a parallel. That's a market pull because somebody needs something and somebody has to provide it. And there's the other thing which it's technology push. And I see in this principle that the universities are the ones that are pushing technology. So are trying to come up with something that's not needed yet, or nobody knows that it's needed, and try to push that forward. So in this sense, in which direction should the universities push, or should there be any, should they define these purple lines? I don't know. Maybe they just should push on the blue lines. And if something pops up which can address a market need, which is the purple lines, then just apply it. I don't know, maybe.
Yeah, thanks for sharing your thoughts. Yeah. I'm also not sure whether we can actually do it, whether we have the capabilities to do so. But I also don't see other entities doing this. And then, of course, related to how I defined the roadmap in a sharp way, in a good setting a real sharp point ahead in the future, and then making a good breakdown into reachable milestones. I don't see that happening. Okay, anyway. I think it's time for your lunch.
Getting closer.
Getting closer, yeah.
The discussions, it's great.
So I would like to thank you for your attention and also like the questions and the interactions. I was helped with it.
Thank you.
Thank you.
I hope you also learned a bit, so thanks.
Thank you.
I would like to also thank Jeroen for this nice presentation and sharing your experience in this field, actually.
Thank you, Essen.
Thank you very much, Professor Jeroen. Thank you very much, Dr. Essen and Dr. Jose, also from your great contributions online. I think they were very good to the discussion here.
I don't know how to shut up.
No, that was great. So with the end of this presentation, we conclude the second day or half day of the second training event. Thank you again very much for the ones that join us online, but also for you that stick together with us in person. And yeah, let's head now to the lunch. Unfortunately, online guests won't be able to join this time, but we hope you can find an excuse to visit us here in Novi Sad sometime in the near future. And yeah, thanks again for the great presentations and participation.
Thank you.
Thank you.
Thank you.
Thank you, Caio.
Thank you.
Caio, I have a last question regarding organizational issues. Can you hear me?
Yes,
Yeah.
Jose.
So I have the content that Israel shared with me. Could you, Claudia, or something, how to proceed with all this? Or maybe you know something, I don't know.
I have an idea here, Jose. Maybe on the